Hi guys, we're on example 2 of using simulation to answer probability questions, okay? We have an example here about a basketball player. It says, suppose a basketball player has an 80% free throw success rate. How can we use random numbers to simulate whether or not he or she makes a foul shot, okay? How many might he or she be able to make in a row without missing? Describe the waiting time simulation of having he or she shoot free throws until he or she misses, counting the number of successes. Okay, this is a little bit different. Basically, our question of interest is, we have a basketball player up at the free throw line. How many free throws can they make on average before they miss? We're going to simulate that to answer the question. So step 1, how many free throws can a basketball player make in a row without missing? Step 2 is our plan. This is how is the trial going to happen? How are we going to use random numbers? When are we going to stop? Can we have repeats? Do we need to throw anything out? Did we get the prescribed condition or not? Okay. We need to now represent the outcomes as numbers, okay? And when we represent outcomes as numbers, guys, what we want to look at is we say, what proportion of the time will that outcome happen? So let's go back. We know it says in the problem that this basketball player has an 80% success rate. So 80% of the time they make it. We need the entire sample space, which means all the outcomes that could happen for that event. We can either make it when we're at the free throw line or we can miss it. So if we make it 80% of the time, we know we're going to miss it 20% of the time. So I'm going to choose to represent this event with 10 numbers, okay? Why 10? Well, it's easy to take 80% of 10 numbers and 20% of 10 numbers. Could I do something different? For sure. I just think the 10 numbers is a nice, easy one to do. Okay, so we have 0 through 9. There's my 10 digits here. 80% of the time we make it. So 80% of 10 digits is 8 numbers. So 1, 2, 3, 4, 5, 6, 7, 8. 0 through 7 will represent a make. 20% of 10 digits is 2 numbers, 8 and 9. That will represent a miss. Okay, now let's go ahead and start writing. How is that simulation going to happen? What is going to happen with that trial? We're going to use a table of random digits here. In the previous problem, we talked about how to use a calculator to generate random digits, but it is important that you know how to use a table of random numbers to also generate this simulation. Okay, so we will use a table of random digits to generate 10 random digits. Each digit will represent a free throw. For each trial, we will go to a line 101 and go across the table by 1 digit. If the digit is an 8 or a 9, that equals a missed free throw, and a 0 through 7 equals a free throw success. We can have repeats. Oftentimes in simulation, we can, when we're dealing with a proportion, I should say that. And we stop once we get an 8 or a 9. Why? Because our question is, how many can we make until we miss? We will continue for 10 trials. Remember, we want a large sample size. I don't always love 10 trials. I think it should be more. But for you guys doing homework at home, we need it reasonable. And then what we'll do is we'll find the average number of free throws we recorded before a miss. So let's go ahead and do this. What I have here is I have our random table or table of random digits. And I'm going to make a table just like I did in the previous problem. Now, in this case, what is our prescribed condition that we're looking for? Not did we get 3 faculty in a row. It's how many baskets did we make until we missed? Okay, just a friendly reminder that 0, right, through 7 equals a make, and 8 and 9 equal a miss. Okay, line 101 will be our first trial. We're going to go across the digit. The first one we see, we have a make, so 1 is a make. 9, though, is a miss, so we stop. How many did we have until how many baskets did we make until we had a miss? 1. Now, you could keep going. The College Board would say that's fine. I just like how it's set up here, as this is like my trial 1, trial 2, trial 3, trial 4. So if you wanted to keep going on the College Board, you would have to make a line here and signify that this was trial 1, and then pick up from there, and then stop again and signify that it's trial 2. I just like this table idea a little bit better. So 1, 9, we stopped at the 9. Okay, I need to erase because it's really hard to read. I'm actually going to change my font right now. I just met my thickness here. Oh, and it won't let me. Okay, so first one was a 7. That's a make. 3, that's a make. 6 is a make. 7 is a make. 6 is a make. 4 is a make. 7 is a make. 1 is a make. 5 is a make. 0 is a make. And 9 is a miss. So we have to stop there. We want to count up all of these numbers, and it does go in chunks of 5. So we just made 10 baskets before we missed. Let's go to line 103. That's going to be trial 3. We have 4 make, 5 make, 4 make, 6 make, 7 make, 7 make, 1 make, 7 make, 0 make, 9 miss. So the trial stops there. We have 5 and 4, which makes 9. We're going to keep going. I'll do one more with you, and then I'm going to pause the video. I want you to do it as well. We'll get our 10 trials over here, and we'll find the average. So I'll go a little bit slower if you need that. We're on line 104. This is trial 4. The first digit I see is 5. That represents a make. The next digit I see is a 2. Again, represents a make. 7 represents a make. 1 represents a make. 1 represents a make. 3 represents a make. And then I have an 8, so I need to stop. I have 5 plus 1. I've made 6 free throws before I've missed. I'd like you to continue this. Pause your video. You're going to do lines 105 through 110, and so am I. When we come back, our numbers should match, and we'll go from there. Okay, so look at your trials. Did you get the same as me? If you didn't, make sure you pause, try it again. Is it plausible I could have made a mistake? I did go a little fast. It is plausible. So you can always reach out to me during class as well to see if you think I made a mistake. All right, so we have our 10 trials here. Okay. What we want to do now is we're not wondering if this was a likely event or not. Okay, this isn't asking that question like it did with the one where we had to pick out how many or what proportion of the time do we think that it would be 3 faculty members when the students cried foul in the previous example we talked about. That's not what this question is asking. It's simply asking, how long does this player have to wait, or how many shots will this player make before they miss, right? So we have all of this data, this quantitative data. When you have quantitative data, that's your prescribed condition, we're going to find an average. In our one before, guys, we didn't have quantitative data. We had yeses or nos, right? Okay, yeses or nos. So that was categorical data. Then we were looking for a proportion of the time that that prescribed condition happens. Not the same here. Quantitative data, we're finding an average. Okay, so on average, we have to wait 3.4 shots until this player misses. Okay, they're going to make 3.4 shots before they miss. Now, I know you can't make 4/10 of a shot, but in statistics, it's just like, I don't know if this is still the truth, but a long time ago, it used to be on average, people have 2.5 kids. You can't have a half of a kid, obviously. That's just how the numbers worked out, okay? So how are we going to say this? We're going to say, based on our simulation, it's always based on our simulation. We have evidence to believe that this basketball player will make an average of 3.4 baskets before the player misses, okay? 3.4 baskets before the player misses. And I believe that was, that ended, right? Okay. So it wasn't irrational. It didn't keep going on and on and on. It was a rational number. So we can just say an average of 3.4. We don't say of about or anything. All right. Simulation, 2 good examples you should have seen. Hopefully you feel somewhat comfortable. We can go through questions in the class. Have a great day, you guys.